Hello everyone. Today we are gonna see how you can integrate pressure and flow through a surface. And at the same time, we're gonna plot a small pressure over distance graph. So as usually, we have already downloaded the file from CONSELF and we open the inside folder, inside of which we can find the openfoam.case file. So we just open it, press apply, and in the simulation, in the results we are checking out today, we have a small impeller. So this is the impeller, a slice actually of the impeller. We go to the last time step, which is currently present in the result. And obviously, as most of you already know, we can color this impeller according to quite a few number of variables which are available. So the first thing to do is, as usually, is a filter that transforms the cell data result to the point data. So we just press apply to cell data to point data filter. Second thing we have to do is, since CONSELF actually report the static pressure in terms of total pressure, as you can see over here, we need to rescale it not to total pressure but to relative pressure. So we just have to subtract the atmospheric pressure. So we just press calculate delta P, and we just want to calculate the static pressure minus the atmospheric pressure, so which is 101,325 pascals. Okay, perfect. So now we have this graph with delta P. Now, in order to calculate the integral, we have first to specify the surface on which we want to integrate. So we just do an extract block, and on the left hand side we can see all the surfaces we divided our impeller in. So we just integrate on the inlet surface. So as you can see, all the impeller vanished away and we just have the inlet right now. And obviously we can now click on integrate variables. Apply. On the right hand side, we now have the value of delta P and the value of the velocity, which are integrated on the inlet surface. Okay, remember that even though we are using the velocity, since it is an integral on a surface, the unit of this is not meters per second, but it is cube meters per second. So this is actually a volume flow. And for the pressure, in order to actually obtain the pressure, we need to divide for the area value of the inlet surface. To do that, we just move to cell data, we get the area value, and we divide, so the pressure 7.33 divided by 0.00033. Okay, so we can move on and see how we can extract a small graph on which we want to plot the pressure against the distance, but not really on the inlet phase, but on the nose phase. So we just use a different phase, this one. We calculate, we have already the delta P, we want to calculate the distance in terms of x distance squared plus z distance squared, because y is the vertical axis. So we just, once again, we press calculate. The calculator, we just create a new variable, we name it distance. So obviously this is the square root of chord x times chord x plus chord Z times chord Z, close bracket, and this is the distance. As you can see, 0 on the left hand side and the maximum distance on the right hand side. So obviously it is possible to calculate any other variable like the angles or whatever. It's just a matter of actually using correctly the functions given by ParaView. So we just want a simple slice of this surface, which is 3D. So I already know the y coordinates at which I'm going to cut the slice, which is minus 0.036. We just press apply. Now, as you can see, we have this small and smooth line on which we want to plot the pressure over distance. So as often as usually, actually, there is a filter to apply in ParaView, which is plot data. So we just click it, we click apply, and this is the filter, the graph. We just have to custom it a little bit. So we specify the x-axis array name, we want distance. We specify the variable we want to plot. Basically, we just have to unselect most of them. So we keep on selecting, except we just maintain the delta P, and we specify the type of markers we want the circles. So this is actually the pressure along these two lines over here divided over the distance. I hope this small webinar was useful and you can now apply it to any sort of results you actually needed.